The universe is 13.8 billion years old. Yet when we look in any direction, we can see galaxies 46 billion light years away. How can we see something 4 times farther than the universe's age in light years? It sounds impossible, but it's one of the most fascinating facts in modern cosmology. The answer reveals how the fabric of space itself stretches and why there are parts of the cosmos humanity will never see, no matter how advanced we become. When we talk about seeing the universe, what we really mean is detecting light. Every photon that reaches us is a message from the past, from stars, galaxies, and clouds of gas that existed long before Earth formed. The farthest light we can detect defines the observable universe. But here's the twist. Light doesn't travel through static space. Space itself has been expanding since the Big Bang. So while that light was on its way, the distance between us and its source kept growing. That's why galaxies whose light left them 13 billion years ago are now 46 billion light years away. Their light has been stretched, its wavelength lengthened, in a process called cosmological redshift. Every distant galaxy is like a snapshot frozen in time. When we look at 10 billion light years away, we see it as it was when the universe was only a few billion years old. The deeper we look, the further back in time we go. Eventually, we reach the oldest light of all, the cosmic microwave background, or CMB. It's the afterglow of the Big Bang, released about 380,000 years after everything began. Before that moment, the universe was too hot and dense for light to travel freely. That CMB light marks the edge of what we can see. Beyond it lies the surface of last scattering, a wall of plasma from the early universe that hides everything before it. We can't directly observe the Big Bang itself, only the fading echo it left behind. But with instruments like Planck, WMAP, and COBE, scientists have mapped that echo across the entire sky, a baby picture of the universe. From those maps, we learned that space is almost perfectly flat and uniform, with tiny fluctuations that grew into galaxies and clusters billions of years later. Today, we see about 2 trillion galaxies within our observable horizon. Each is moving away, carried by the expansion of space itself. But beyond that horizon, there are countless more we'll never detect. Their light hasn't had time to reach us, and because the universe is still expanding, it never will. The observable universe is like a growing sphere of knowledge, limited by the speed of light and the age of space. Every year, it expands by about 1 light year in radius, not because new galaxies appear, but because more ancient light finally arrives. Yet, paradoxically, while our horizon grows, the actual universe expands even faster. Many galaxies we can see today will drift beyond our horizon in the distant future, their light forever stretched into invisibility. The boundary that separates the visible from the invisible is called the cosmic event horizon. Anything beyond it recedes faster than light relative to us. No signal, no photon, no future observation can ever cross it. It's not that those galaxies move through space faster than light. Instead, space itself expands faster than light can travel through it. Relativity still holds perfectly. It's just that the stage itself is stretching. This is why distance in cosmology is a tricky concept. The farthest object we've ever observed, the GN-Z11 galaxy, appears as it was only 400 million years after the Big Bang, but it's now over 32 billion light years away. And that's just within reach of the James Webb Space Telescope, whose infrared vision captures the faintest light, stretched by billions of years of expansion. Every photon JWST detects is a survivor, a particle of light that's traveled across expanding space since the dawn of galaxies. By measuring how much that light has been stretched, astronomers can reconstruct how the universe has changed over time. There's a rule written into the fabric of reality. Nothing can move through space faster than light. But space itself, it plays by different rules. This is the key to understanding why we can never see the whole universe. As the universe expands, distant regions move away from us, not because they're flying through space, but because the space between us and them is stretching. Imagine dots drawn on a balloon. As the balloon inflates, the dots drift apart. None of them are moving on their own, yet the distance between them grows. That's what's happening on the largest scale possible. This means that, far enough away, galaxies are receding faster than the speed of light. Not because they break relativity, but because the fabric of spacetime stretches faster than light can bridge it. We call the boundary beyond which light will never reach us the cosmic event horizon. It's currently about 16 billion light years away. Anything beyond that is gone forever. Not destroyed, just unreachable. When astronomers observe a distant galaxy, they're not seeing it as it is now, but as it was billions of years ago. Many of those galaxies no longer exist in our observable universe. Their light is all that remains visible to us. Even light itself stretches as it travels, its wavelength elongated by expansion. That's why ancient galaxies appear red. The cosmological redshift literally pulls their color toward the red end of the spectrum. This stretching also robs photons of energy, cooling the universe over time. Today, the cosmic microwave background glows at just 2.7 Kelvin, only a few degrees above absolute zero. As the expansion continues, more and more galaxies will cross the event horizon. Their light will never reach us, no matter how long we wait. In fact, right now, roughly 97% of all galaxies are already forever beyond our sight. That's hard to imagine. The visible universe, enormous as it is, represents only a tiny fraction of the whole cosmos. We are inside a small, luminous bubble, surrounded by infinite darkness we can never explore. Even if we built a telescope the size of the solar system, even if we waited 1 trillion years, there's a limit to what light can tell us. Because visibility isn't about how far we look, it's about how far light can travel through an expanding space. The faster space expands, the smaller our visible fraction becomes. It's like standing in a storm that keeps stretching the world faster than you can see it fade. The universe's expansion rate, known as the Hubble constant, determines how quickly new regions vanish beyond our cosmic horizon. Today, that expansion speed is about 73 kilometers per second per megaparsec, though precise measurements still spark debate. This limit also defines the Hubble sphere, the region where galaxies recede from us exactly at light speed. Anything farther than that expands faster than light, and its light can never reach us. But unlike a wall, this horizon isn't fixed. It moves as time goes on, reshaped by dark energy and cosmic expansion. In a sense, we're floating inside a moving boundary that defines the edge of everything we can ever know. The future looks even stranger. Billions of years from now, the acceleration caused by dark energy will push every distant galaxy beyond our horizon. Only a few, the ones bound by gravity in our local group, will remain visible. When that happens, future astronomers will see a sky almost empty of galaxies. No clues of expansion, no cosmic background, no evidence that the universe ever extended beyond their own galaxy cluster. They'll look up and see darkness, not because the universe ended, but because light could no longer reach them. It's ironic. The more we learn about the universe, the more we realize how temporary our cosmic perspective is. Right now, we live in the perfect era, when the sky still carries light from the ancient past, before it slips beyond reach forever. We are cosmic witnesses in a brief, luminous moment, able to see across 13.8 billion years of history, but destined to lose sight of most of it in the future. What lies beyond the edge of what we can see? Probably a lot. Galaxies, clusters, even cosmic structures we'll never detect. Because the observable universe isn't all that exists, it's just the part whose light has had time to reach us. Scientists estimate there are hundreds of trillions of galaxies outside our visible range. Their light is still on the way, but the expansion of space will stretch it forever before it arrives. We'll never see those regions directly, but we can still infer their existence. Cosmic simulations, gravitational waves, and even neutrino observations help map what's beyond our horizon. The James Webb Space Telescope has already reached back over 13 billion years. Next-generation missions like Euclid and Roman will chart even fainter galaxies, right up to the edge of visibility. But even those instruments can't see beyond time itself. No technology can outrun cosmic expansion. There will always be more universe than we can ever observe. So, how much of the universe can humanity ever see? Only a fraction, a tiny shimmering bubble in an endless ocean of space. Roughly 2 trillion galaxies inside our horizon, and perhaps 100 times more, forever beyond it. The light we detect today is precious. It's the record of everything the universe has allowed us to witness. Each photon that reaches us, is a survivor of billions of years of travel through an expanding cosmos. One day, that light will fade, the universe will keep expanding, and distant galaxies will disappear beyond sight, one by one, until only our local group remains, a small island of stars in an empty sea. But right now, at this exact moment in cosmic history, we can still see it. The full arc of 13.8 billion years of light, stretching across the sky. We live in a special window of time when the universe still tells its story through starlight. And maybe that's the most remarkable thing of all, that a species on a small blue planet can look up and glimpse nearly the entire observable history of reality itself. If this video helped you see the universe a little differently, don't forget to support the journey. Subscribe for more science-based space stories explained simply and visually. Because every time we look up, we expand what it means to see.